Okay, students, now we are in the chapter of ionic equilibrium, the most difficult, most scoring chapter of the class 11th, first year or class 11th. Okay, so but if it is solved with the tricks and with the detailed explanation of few models of the previous exam, then it will be easy for you. I will try to explain in such a way that only not these questions, similar type of questions you will be able to solve, and what type of difficulty students faced during that examination, which was the wrong attempted wrong and why it was attempted wrong, what was the misconcept in the students, that all also I am going to explain. Okay, there is a lot of difference of doing yourself and listening to my video lecture with tricks and detailed explanation. Okay, so I hope all chapters you will go through the previous year question. The very first thing you will do, go through the one shot lecture. Okay, the best procedure in the shortest possible time is what you have to do. You have to go through the, as a first step, you will start the one shot. Okay, one shot lecture. Then after one shot lecture, go through the PYQ, previous year question. Okay. Then you can select the topics. After these two, you will get some topics difficult. Like some people have problem in the buffer solution. They are not able to solve the buffer solution. Some people are having problem in titration. Okay. Some people are having finding out the pH of mixtures. Okay. So pH of mixtures also one of the important topic. So like that you select the topics which during one shot, during PYQ, which topic is your weak area. So then go through that chapter. Okay. Then your preparation is up to the mark or not, then you can select the DPP. Okay. So if you follow these four steps, definitely your score will improve and you will get 99 percentile in the IIT mains, and you will definitely get seat in the NEET exam. AIMS seat you will get in the NEET exam. Okay. So I think all of you will follow this procedure. One shot followed by PYQ. During that only you should select the topics. Okay, which topics I have to work on, then you will go through the DPP. Okay, so let's start with the questions. Now you should be in mood to what I have to do, solubility product or which topic I have a problem, that you will select. Okay, so now let us start with one by one question. Okay. Okay, now first question is here. 2 ml 2 ml of 2 by 5 2 by 5 molar weak mono basic monoacidic base Kb is given, is titrated with 2 by 15 molar HCl of water at 25 degrees Celsius. Then the concentration of H plus at equivalence point is. Okay. Okay, here is the question given is of the salt hydrolysis. Question is of the salt hydrolysis. Okay. So in this question, how you will come to know what type of salt it is? Here Kb is given and HCl is used. Therefore, the salt formed, the salt we get is of the HCl is a strong acid and BOH is a weak base because Kb is given. So whatever the salt we are getting, that is of salt of weak base and strong acid. Okay. Now in this one, volume of HCl, actually at equivalence point, number of moles of acid, should be is equal to number of moles of base. M1V1 is equal to M2V2. Okay. HCl volume is not given. That's why what I am doing, by using the base, okay, and acid concentration, then you will get volume of volume of HCl used. Okay. Then once you know the volume of HCl, So total volume will be base we have used 2.5 ml and sorry acid we have used 2.5 ml. Okay, this is the base we have added initially. And the acid for neutralization, how much we have taken? Acid we have added to for neutralization. So total ml, total volume of solution will be 10 ml. Okay, and moles will be same 2.5 by 2 by 5. Either you can take this one or this one, you will get same moles. So moles upon volume, you got concentration of salt. Okay, what you will get? This is the concentration of salt. These are the moles of salt. This is the volume of salt. Now, question is about the concentration of H plus. C alpha. Normally, if it is acid, it will be C alpha. But it is a salt, therefore C into H. In place of acid, we will take alpha. In place of base, we will take alpha. But in place of the salt, we will take degree of hydrolysis H. Okay. And same here, alpha is equal to C alpha square. For alpha, what we will take? C alpha square upon 1 minus alpha. We will get Ka or Kb. But it is a hydrolysis constant. Therefore, Ch square upon 1 minus H, Kw upon Kb. Kw is 10 to the power of minus 4. Kb you are given with. Then you will find out hydrolysis constant as 0.27. How much it is? 0.27. So if I put H is equal to 0.27 here and concentration as zero point 0.1, then H plus concentration will be 2.7 into 10 to the power of minus 2. Okay. So 2.7 into 10 to the power of minus 7, minus 2 is the H plus concentration. H plus concentration is 2.7 into 10 to the power of minus 2. Okay. Note down this. So according to our solution, which answer is matching? D option is matching. Our answer 2.7 into 10 to the power of minus 2. Therefore, D option is matching. Okay. So first of all, you should be able to identify the topic itself. Here, nowhere the question is mentioned. It is a salt hydrolysis question. That's why going through the video solution will give you the hint. Okay. Here it is given base, weak monoacid base and salt HCl. Therefore, salt hydrolysis question. Okay. Now let's see the next question. Okay, next question. Solubility product constant, that is KSP, of MX, MX2, M3X are 4 given. Solubility is in mole per dm cube of the in the order of. Okay, which is having more solubility, which is having less solubility, that you have to arrange them. Okay, you can solve, otherwise I will try to explain it. Okay. Okay, here, see, this is of AB2 type. First one is AB type, therefore S will be cube root of, okay, square root of 4 into 10 to the power of minus 8. That means 2 into 10 to the power of minus 4. Here S2 will be, this will be 4. Like that you can calculate S2, like that you can calculate S3. Still solubility will be more over here. Here if it is cube root also, it will be 10 to the power of minus 5 somewhere. Okay. It is also 10 to the power of minus 5 somewhere. Okay. But it will be 1 into 10 to the power of minus 5. And here you will get on simplification solubilities. You will get this as order. Okay. Mx will be obviously highest. And Mx highest, then M3X will be second highest. And third highest will be Mx2. Okay, is that clear to all of you? So you can solve and you can cross check. This is my answer. Okay, so it may or may not be correct, so, but you should try. Next, aqueous solution of HNO3, KOH, CS3COH and CH3CONA are identical concentrations are provided. The pair of solution which form buffer solution on mixing. Okay, so buffer is a mixture of salt of weak acid and base and weak base, or same way weak acid with salt, like that you should be able to identify which is ready to form, the buffer. Is it understood? Let's see who will answer. Okay, for any buffer, salt is also must, and weak acid or weak base or at least acid must be present. Okay. So if this question is only single correct answer, okay, that time this will be the answer. Okay. This will be a problem because HNO3 is a strong acid. It will form buffer but less effective buffer. So most appropriate answer is D because it is salt is also there and salt with weak acid also there. Is it understood? This is salt and strong acid also okay, but here this is base and salt. Okay, there is no K here. It should be K at least, and it is strong acid and both acid can never form a buffer. For buffer, salt acid, salt base like that it is must. Okay, so I think it is clear to all of you. Now let's see the next question. Okay, next question is here the KSP of Ag to CrO4 is given. Then solubility of Ag to CrO4 in zero point 0.1 molar AgNO3. This is a question of common ion effect. And once exam was there, I think it is K set. Okay, in K set they have changed this mole into gram per liter. Okay, so that will be different. In gram per liter, then you will use the molecular mass. But anyhow, it is advanced examination 2013 paper 2. So, but here it is not gram per liter, it is mole per liter only. But it is common ion effect. So this silver is going to show the common ion effect with the Ag to CrO4. Okay. So I'm writing the hint here so that you can try. Ag to CrO4 reversible 2Ag plus CrO4 2 minus. Okay. So this is 2S and this is S. Now in that AgNO3 is added. What is added? AgNO3. So AgNO3 is a completely soluble salt because its KSP is not given. Okay. So this will be Ag plus NO3 minus. So its concentration, whatever given, the same you will write. Okay. Now KSP. KSP is equal to concentration of Ag plus whole square into concentration of CrO4 2 minus. Okay. So Ag plus concentration is how much? 2S. Ag plus concentration is 2S plus zero point 0.1 whole square. And here it is S to the power of 1 is equal to how much? 1.1 into 10 to the power of minus 12. So here you can neglect this 2S. So this will be 10 to the power of minus 2 into S is equal to 1.1 into 10 to the power of minus 12. So solubility will be 1.1 into 10 to the power of minus 10. This is what the process to calculate the solubility if common ion effect is given. Okay. Next question is pKa of weak acid Ha and pKb of weak base are 3.2 to 3.4. Then pH of their salt will be. Okay. So this salt is of weak acid and weak base. Okay. So in that concentration will not be effective. What will not be effective? Concentration will not be effective. Okay. Okay, here it is a salt of both weak acid and weak base. So simple formula will be pH is equal to 7. Acid will be added plus pKa minus half of pKb. This is the formula. Simple thing you will remember, acid will be added, base will be minus. Okay. So 7 plus half into pKa is 3.2. And minus half of pKb is 3.4. Okay. So on simplifying, I think you should get somewhere around how much? 6.9. How much you will get? 6.9. So answer is C option. Okay. Note down this. Okay. Next question. In alkalis titrated against a strong acid, with methyl orange indicator. Which one of the following is a correct combination? Okay. Acid is strong and end point with methyl orange indicator. Okay. Okay, here you are given with the acid. Okay, so in all cases you can see acid, alkali is titrated against acid. Okay, that means alkali is there in the conical flask and we are adding the acid. Okay, if acid is strong, then end point will be actually methyl orange, range of the methyl orange will be 3.9 to 4.5. So if it is less than the 3.9, then it will be pinkish red. This is about the indicator. Okay. There is a special lecture for the indicator. Those who are aspiring for IITs, definitely they should go for the indicator lecture. Okay. So all lectures separately, for titration separate, mixture of acid and base separate. Okay. So these values already I have given, and how to find out the pH at equivalence point, end point, the differences already I have given. Okay. So for pinkish red, for yellow to pinkish red, already we have the alkali. So that means base pH will be more than 7. So more than 7, it will be yellow color starting. So once you keep on adding the acid, then it will reduce to the red, pinkish red. So answer will be yellow to pinkish red. Therefore, D option is correct. Okay. Then which one of the following are Lewis acid? For Lewis acid, acid should accept. This is a memory technique. Acid accept. Okay. What does it do? Acid will accept lone pair of electron. And both should be acceptor. Both should be acceptor. Okay. So simple thing with the electron deficient center should be the both. Okay. So here boron also electron deficient. It got only 6 electron, and aluminum also electron deficient because it got 6 electron. Therefore, the answer will be A option. Okay. So try to mark this type of difficult question, and immediately after this one shot, you should go through that related lecture. Okay. Okay, now let us see the next question. Next question is which one of the following salts is the most basic in aqua solution? Okay, so here all are he itself saying that they are salt, but they wanted that basic should be there. Okay, so for basic nature, acid should be weak, base should be strong. Okay, so let us take this one. It is made from the weak acid. It is made from what? Weak acid, and but base also relatively weak. So strong base, weak acid is made by this one. When it is hydrolyzed, it is giving CH3COOH and it is giving KOH. KOH being the strong base, so the resultant solution will be basic only. Okay. How to identify? Is it clear? Like this is a weak base, strong acid, so acidic. Weak acid, weak base, neutral almost. Here, weak acid, weak base, neutral. So strong base should be there. KOH being strong base, so answer will be C option. Okay. Why answer is C option? I think it is clear. Okay, now next, maximum prescribed concentration of copper in drinking water. Okay, in drinking water it is 3 ppm. It is what? 3 ppm. Okay, now let's see the next questions. Okay, 20 ml of 0.1 molarity this one. H2SO4 added to 30 ml of zero point 0.2 molar, sorry, this is NH4OH. Then the pH of resultant mixture is, okay. So this is again a buffer, it can be buffer, it can be salt solution. So that you have to decide on your own, okay. So how you will decide? 20 into 0.1 into 2, okay. So number of moles of H plus will be, number of moles of H plus will be 20 volume, okay, into 0.1 molarity, and each sulfuric acid will give 2, okay. So the answer will be number of moles of H plus will be 4, and here OH minus will be 30 into zero point 0.2 into 1. Only one OH is there. So it will be 6. Therefore, base is extra, acid is less. So therefore, it will form what? Buffer solution. What it will form? Buffer solution. And which buffer? Base is extra. Therefore, it will form basic buffer. What it will form? Basic buffer. So use the basic buffer formula. POH is equal to pKb plus log of salt upon base. Okay, salt upon base. Now, by substituting in this formula, you will get C option as a correct. Which option is correct? Here pKb will be 4.7 plus log of salt concentration will be lowest one. 4. Okay. Salt concentration will be 4 divided by base extra will be 2. Okay. So on this simplification you will get this is POH, but question is about the pH. Okay. Question is about what? pH. So this will be 4.7 plus 3.3. This will be 5. POH is 5. Therefore pH will be how much? 14 minus 5, that is 9. What is the answer? pH will be 9. Okay. Note down and then let's move on to the next one. Okay, this is the most repeated question. pH of rainwater approximately. Every time there will be question and most of the people think that how to remember, why to remember. Okay. But it is most frequently asked question. Okay, actually this question is not to remember. Simple acid rain you will listen, you will never come to know base rain. Have you ever listened? Acid rain. So acid means should be less than 7 and it is 5.6, approximately 5.6. This is clearly given in NCERT. Okay. It is not out of the syllabus. It is not much difficult question, but you should remember. Okay. Now let's go on to the next one. So this is a matrix match question. Okay. Now let me read out the whatever the things it is given. Dilution process of different aqueous solution. Okay. Dilute process of different aqueous solution with water are given in column 1. The effect of dilution of the solutions on H plus in column 2. So that means when you add water to the mixture, what will be the H plus concentration that you have to identify. Okay. So that question, I think it is clear. On left hand side, to what water is added. On right hand side, after adding the water, what will happen. Okay. First here it is given NaOH and acetic acid diluted with 60 ml of water. Okay. Then second 20 ml of zero point 0.1 molar NaOH, 20 ml of 0.1 molar acetic acid diluted with 80 ml of water. Then ammonia solution HCl diluted with 80 ml. Saturated solution of nickel hydroxide diluted with solid NaOH. Okay, still present after dilution. Okay. So accordingly, there are 5 options are here. Understood? This is an advanced question 2018 recent paper 2. Okay, so here I am writing the answer to this. When you add water to the NaOH and acetic acid diluted to 60 ml, the value of H plus does not change because it is a buffer solution. It is a salt of weak acid. This weak acid will be there because 20 into 0.1. This will be 2 and this will be 1. So some salt will be there, some base will be there. Therefore, it will form a buffer and pH is equal to pKa. Here pH value will be exactly equal to pKa. So there is no change in the concentration of H plus. Okay, A option will be 1. Like that you can compare. B option will be 5. Okay, and C option will be 4. Procedure I have told you, and D option will be 1. Wherever buffer is there, Wherever buffer is there, saturated solution is there, then there won't be any change in the pH. Okay. So this is about the answer. Now let's move on to the next one. Okay, next one. This is an integer type question. Sorry, paragraph question. First, let us read the paragraph. When 100 ml of 1 molarity HCl mixed with 100 ml of 1 molarity NaOH in insulated beaker at constant pressure. So this is neutralization. Acid plus base will give you the salt plus water. Okay, that heat is given as 5.7 and enthalpy of neutralization is 57. So calorimeter in the second experiment, 100 ml of 2 molarity acetic acid mixed with NaOH. Here it is a weak acid, strong base, and here it is a strong acid and strong base. But temperature increased only by the 5.6 because heat released is less in case of the weak acid. Okay. Now delta S and specific heat of water is specific heat capacity of water is 4.186, but he is asking us to take 4.2. Okay, so depending on this some questions are there. Let us move, let us read that. Okay. Okay, now let us see the enthalpy of dissociation of acetic acid. Actually, it is supposed to be how much? 5.7 it is supposed to be, but it is how much? 5.6. Okay, so depending on how much it is less than per mole, you can calculate this one. Okay, can you calculate or not? Okay, if you're calculating, then enthalpy of neutralization you will get 5600 only. Okay, but how much you should have? It should be 5700. Okay, then only zero point 0.1 will be there. How much will be less? Only zero point 0.1. So 1 kilojoule. Okay, 1 kilojoule is only left over. Okay. Okay, then pH of solution after experiment 2. So as it is a weak acid and weak base, okay, weak acid and strong base, or NaOH is a strong base, it will form the buffer solution. In the buffer solution, pH is equal to pKa plus log of salt upon acid, okay. And here neutralization is taking place. This will be become 1 and pH is equal to pKa. So pKa is already given as 4.7. So answer will be B option. Okay. Now let's see the next question. So dissociation constant of a substituted benzoic acid at 25 degrees pH of one of the sodium salt is, that means salt solution. What it is? Salt solution. Okay, so pH you have to find out. Benzoic acid is a weak acid. Okay, and sodium salt, so salt will be salt of weak acid. Okay, salt of weak acid and strong base. So in that you can find out this is given as a C and this is Ka. So once you know the Ka and C, you can easily find out the pH is equal to pKw, half of pKw minus plus pK, half of pKa plus log C. Okay. So then you can find out by that formula. Simply you should identify which formula you have to use. Okay. Is that clear to all of you? Now you will get answer of 8. How much you will get? Answer to this question will be 8. Next, among the following total number of compound whose aqueous solution turns red litmus paper blue. Okay. So red litmus paper to blue means basic solution. Okay. So KCN is a weak acid and strong base. Therefore, it is base. Okay. So but K2SO4 is both are equally. So it will be neutral. Like that, you should see this is a weak acid, weak base. So it cannot be. Weak acid, weak base, it cannot be. Zinc nitrate, it cannot be. FeCl3, it cannot be. Okay. Only base must be strong. So this is a base. And same way LaCN is a base. Okay. So only answer will be 1, 2, 3. What are the answer? KCN, K2CO3, LaCN. Answer will be 3 substances which will turn red litmus to blue. Base loves blue. Okay. How you will remember? Base NaCl is neutral, so it cannot turn. Okay. So NaCl is a neutral solution. That's why it does not change the color of the paper. Is that clear? So here you are given with the solubility of salt of weak acid. Okay. What is given? KSP. pH is equal to 3 means concentration of H plus is equal to 10 to the power of minus 3. And value of Y is, okay, AB salt KSP is given, weak acid Ka is given. By using all of them, you have to find out solubility of weak acid. Okay, AB you have to find out. Okay, it is just like a common ion effect. Understood? Here common ion is what? Base, acid also provide B minus, salt also provide B minus. So by using the common ion effect question, you can solve, then you will get the solubility as 4.47 into 10 to the power of minus 3. Okay. H plus concentration is given and B minus solubility will get from here, then you will get the solubility. 4.47 into 10 to the power of minus 3. Is it clear?